Welcome to lesson 4 and 5 exponential functions with transformations. Part 1, we're going to look at a and k. What do they do? To begin, we're going to look at the base. So this is from our previous lesson, lesson 3. What's it look like? The y-intercept of the base function will always be 0, 1. Domain, no matter what happens, is XCR. Range for this guy, y is greater than 0, y not equal to, because there's an asymptote at y equals 0, and the asymptote will be y equals 0. All right, let's continue. So here we're going to look at transformations with a. So we're going to be looking at this guy here. Just excuse me for 1 second. So we're going to look at what happens with our coefficient. So we're going to go to the graph. Our graph looks like this. And so we're going to play around with different a values. So our first a value we're going to look at is 3. So I'm going to go shift this guy to 3. Here we go. There we go. So you can see that what's happening is it's become vertically stretched. Our next one is 1/2, so I can shift this guy to 1/2. There we go right there. Whoops. Probably should do this with a mouse. There he is. So you can see it's been vertically compressed. And then finally, -1. So here I'm going to go down to -1. So here you can see it's been reflected through the x-axis. So here we go. If we record these, we can see that this is our base one. Here we can see the y-intercept changes, the domain stays the same, range stays the same, and the asymptote stays the same. Here again, our y-intercept changes, domain, range stay the same, and our asymptote always stays the same. Here, our y-intercept changes to -1. Why? Because our a value is actually -1 here. Domain stays the same, asymptote stays the same. The range actually does change. How does the range change? Because now it is less than 0. Y is less than 0, Mr. Wills, because it's been reflected through the x-axis. So what's changed here? Things that have changed is our y-intercept, our range only if the a value is negative, and the things that stay the same are the domain and the asymptote. In general, y equals 0a. This is only if there is no h or k and my b value is 1. Okay. So if a is greater than 1, vertically stretched by factor of a, between 0 and 1, vertically compressed by factor of a, and if a is negative, reflected through the x-axis. I'm not going to spend any time on that. That is a unit 3. We also did that in unit 5. All right, let's look at the next one. Our next one looks like this. So here we go. So we're going to talk about the k value, that constant at the end. And again, we've got the base, which doesn't change, of course. We know that one already. Now here, if we change our k value to +3, so I'm going to go back here. I'm going to switch this guy back to 1, which is right here. And I'm going to switch this k value to 3, so we can see it's being shifted up. And so I can record the data here. Y-intercept is 0, 4. This and this, range changes, and the asymptote also changes, so a lot has changed here. And then -2. So shift this guy down. Here we go, down to -2. There we go, right there. So we can see that y-intercept's changed, asymptote's changed, and the range is all changed. So record this. Where are you? So we have this, -1, that changes, or that doesn't change, of course, domain doesn't change, but the range changes and the asymptote changes. So what has changed? These three. What has stayed the same? Our domain. All right, how can we write this up? Well, this is actually probably the most complex. This one changes actually the most. Our y-intercept will always be y equals a plus k, and again, this is only if there's no h value and our b value is equal to 1, which we'll talk about in a few minutes. Our range, y is greater than k. This is if a is positive. So if a is positive, and then the other one here is less than k, and this is if our a is negative. All right, if k is greater than 1 or greater than 0, vertically shifted up k units. K is less than 1, vertically shifted down k units. We saw that already. Let's continue. Here we go. Talk about increasing, decreasing functions. If a is positive and n is positive, or sorry, n is greater than 1. And this here, this one would actually go with graph 2. So I'm just going to write here, this guy here is graph 2, G2. And so here, this is increasing. Why? What's increasing? Increasing means when x goes up, that means y also goes up. So as my x goes to the right, my y values are going up. So we call this a increasing function. Next one. If a is negative, so reflected, but n is still greater than 1, so that would be basically graph 2, but reflected through the x-axis, so that's going to be graph 4. So this guy here would be graph 4. And as you can see, graph 4, as my x values get bigger, my y values start going down, so we call this a decreasing function. When my a value is positive and n value is between 0 and 1, that would be graph 3, this guy here. Oops. So graph 3, and graph 3, as my x values go to the right, we can see my y values are getting smaller and smaller, so this is decreasing. For process of elimination, my last one here is a value is negative, and my n value is between 0 and 1, so this has to be, oops, graph 1. So basically what it is graph 3, but reflected to the x-axis, so it is graph 1. And this is a increasing function. All right, let's continue. So here we go. Now we're going to talk about what do B and H do, and if you were paying attention to Unit 3 and Unit 5, we should know what these do already. But here we go. Here's the first one. So I'm going to play around with my H value here, and my H value is added or subtracted to X. What is H value? So the first one, this is no transformation, so of course we know that. There we go. Now if H is negative 2, so I'm going to go back to this graph here. Let's make sure all my values are good. All right, so let's go back to 0. And if my, B value is, or my H value is negative 2, so there we go. So you can see it's shifting it to the right 2 units. And so my y-intercept is there. So my y-intercept will be 0, 0, and 0.25. This doesn't change, and this doesn't change. If I do plus 1, so I go back to my graph here, I'm going to shift this to plus 1. There we go, right there. So you can choose shifting it to the left. And I can see my, do that. My y-intercept is 0, 2. So my y-intercept is 0, 2. But nothing else changes. So the only thing that changes here is my y-intercept. Domain, range, and asymptote all stay the same. So the H is shifting it left and right. So if H is positive, shifted to the right, or shifted it H units to the left. And if it is negative, it is shifted H units to the right. Finally, let's look at what the B value does. The B value is right here beside X. It's being multiplied into the X. The first one, well, nothing has changed here. So we'll just make sure to write that in. If my B value here is 2, so I'm going to go back to my graph. Here's my graph. Let's make sure everything is 0. That's 0. Let's move this H back to 0. And so now my B value is 2. So here we go. You can see it's being horizontally compressed. But nothing else changes. Horizontally compressed, but the asymptote and range and y-intercept all stay the same. B value is 0.5. Shift it over 0.5, which is right about there. So you can see it's being horizontally stretched, but nothing else changes. These 4 properties remain the same. So what's happening here, domain, range, asymptote, and y-intercept stay the same. Okay. So if B value is greater than 1, we say this is horizontally compressed by a factor of 1 over B, just like Unit 3. Between 0 and 1, we say it's horizontally stretched by a factor of 1 over B, and B is negative. We didn't really look at this, but we'll say as reflected through the y-axis again if you want to see that. So here it is, my b is 1, and let's look at b as -1. We can see that it's reflected through the y-axis, positive, negative, positive. It's like the exponential dance. Negative, all right. And that is transformations. The next video I will do a few examples for you.